See what the table we created yesterday and what are the constraints we applied on each, each column or kind. We'll see. So we can give it back some what the constraint, what are the types of constraint we have. We'll recap the things. Okay. See, constraints will apply specific rules to the data, ensuring the data conforms to the requirements defined. See, based on your requirements, if you want to define any rules on the tables, okay, we'll use the constraints for that. Okay, so we have different kinds of constraints: primary key constraint, init constraint, not null constraint. See, not null constraint will help us to restrict the null values on any particular column. Okay, then we have init constraint. Init constraint will help us to restrict the duplicate on the particular column. So if you want to do the both actions on the same column, so you can make it as a primary key for this. You can make it as a primary key for that particular column. Okay. Then we have a check constraint. The check constraint will help us to validate the information to prevent the wrong data. So we'll use, see, it is used to check the condition or it is used to validate the data before inserting the data into the column. Okay, before this we see about yesterday and we see about, we saw about already, default constraint also. Okay, see, it is used to insert the default values on the column. Okay, so where you are not providing any value for the particular column, so the system will automatically insert the default value for that particular column. Okay, this is what we yesterday we covered everything till now this, right? See, and we have other thing, other things like composite primary key. See, actually we can able to derive the constraints at two levels. Actually, we can able to derive the constraints at the two levels. One at the column level and one at the table level. Okay, see, we can able to derive the constraint at the two level, table level, and as well as the column level. See, what are the, so you are deriving like as a column name. Besides of that column name, you are mentioning like a primary key. This is like a column level derivation. So if you want to make it as a table level of any constraint, simply see you now I'm creating this table here. The table is derived with primary key constraint. This we can call it as a like the derivation of this constraint as a column level, because your family is having these three persons: status ID, person ID, active record. See, treat like I say, my status is the table, and this table I am treating like as a family. Inside that, I'm seeing the three different members in this, and I'm making the constraint for this particular member. So this constraint is dedicatedly for this particular column, not with the entire table, not with the entire table. So in such case, where we need to derive the logics for that particular column only, in such place, you can go with the column level derivation of the constraint. Okay, where we need to put with the family level or more than one person. See, where we need to define the constraint at the table level. Okay, so for that reason, you cannot able to see. Now I need to make the duplication restriction and null values restriction on these two columns itself, two columns. See, in such place, I cannot able to derive this primary key. See here, now I'm trying to make with the primary key with the, now I'm dropping this table. And I'm trying to recreate. See, it is giving the error. I cannot able to use the primary key column more than one time on the same table because table can have only one primary key on a table. This we can call it as a, it is giving the error, right? See, now you need to derive this constraint for two columns. The composite, you can able to derive at the composite constraint. See, now you are able to derive this. Now I'm removing this and I'm trying to create, right? See, till now you haven't provided the constraint name. You mentioned the constraint type is a primary key. See, if you are creating the table is stored in a user underscore tables. User underscore tables, right? If these contain only the table, what is the table name, what is the table space you are using, this information will contain. See, what are the columns we have inside the table? You are creating the table and you are creating inside the, what are the columns we have in that particular table. That also you can able to get in user underscore tab underscore calls is another data dictionary table. See that in table underscore name equals to master. See, account number is the column, name is the second column, gender is third column, current balance is the last column. Maybe if you remember that, so that you will get this column ID. This is the first column, second column, third column. So it gives the position of that particular column, the column ID values. And data type, what is the data type for that particular column that you will see in this data type column. And length, the size of the data type which you mentioned that you will see in this particular column. So for number data type, it will see the 22, but rest you will get the correct information here. Okay. See the precision, if you mention like out of 22, what is the precision value, what is the scale that you will see in this particular point. If you mention like simply number, we will see the data length is 22 and data precision and scale values are null. If you mention the number of 13, see, you can able to see you created this table, how you created this table that you don't know, like, right? See, select this table name and right click on that. Go to the open declaration option. Okay, go to this open declaration option. Select star for this. Okay, so now I'm go to the open declaration tab and see this how we have the lot of tabs in this columns. What are the columns we have? What is the data type we have? See 13.0. So you mentioned like number of 13. The scale value is default it is taking 0. Car 2, 32, car of 1. See everything is showing in this. If you have any data, you will see that in this table and tab. Okay, so if you have any constraints on this, you will see this constraint in this particular place. Okay, and go to the SQL. How you created this statement, the DDL statement, create table, table name, the kind. See, my system having the trouble. So you may get in your mission. So right click on the table and go to the open declaration tab and choose, click this SQL tab and you will see the DDL statement inside this. Okay, now I'm unable to get here, right? So earlier we don't have these tools and all those things. You can able to get the DDL statement for any table or any database objects. So if you want to know that, dbms underscore meta data. See, whatever the information you are doing and capturing by the Oracle, that we are storing in the meta objects. See, user underscore tables is a meta object. User underscore indexes, user underscore anything like a already system defined tables, what are the things we are using commonly for all the users, that we can call it as a data dictionary tables or meta objects. Meta objects. So if you want to get the metadata, if you want to get anything from the metadata, you need to use dbms underscore metadata is the procedure package for that. So now you are looking for the DDL statement. So get underscore DDL is the function. Get underscore DDL is the function. So now you are looking for the object, for which object you are looking, that you can mention here, and table. So what is the object type of that? From real. Invalid input account master. See, object type and object name you need to provide. See, so for which object you are looking for the DDL statement, for what type of object you are looking for the DDL statement, that you need to mention here, table and the object name. Now see, you will get the data. How we created the data, DDL statement yesterday, that you are going to get here. See, if you are creating the table, it automatically creating the segment creation immediate. So while creating the table itself, see, you haven't done anything. You haven't mentioned these parameters yesterday. We haven't provided these parameters yesterday, right? So the system will do some activities from backend. So the segment creation can happen. If you haven't mentioned this, it automatically mention like a segment creation immediate option. And we'll see the table space name. By default, it will create the table space as a system. See what the user, whatever the user is having the default table space, that is going to mention in this way. Okay, then we don't have any other things here. Okay, so this is what happened yesterday, right? So you mentioned like a number of 13, 0 and a char of 1. Everything is same. This is the way you can get this. Okay, now I'm removing this all the parameters. Okay, so now I'm trying to see some how if you are creating the constraints will get stored in the user underscore constraints on any table. See, you are not seeing any constraint information in this particular table. So the table is having the constraints, right? But you are not able to get that particular information. User underscore constraints. The table is get stored in user underscore tables. The same way, the constraints also get stored in the user underscore constraints, where table underscore name equals to account master. See, you are seeing like a lot of options, a lot of constraints in this. See, here you are seeing like owner is a batch 14. What is the schema name? What is the user you logged in, through the which user you logged in, that you will get in this case. And constraint name. See, we are creating the constraint, but you haven't provided any name for that particular constraint. See, Oracle is by default it creating some their own name. Oracle is by default it creating their own name as a sys. See, every name is having like sys underscore C008624252627. It creating that their own name by Oracle itself. If you haven't provided the constraint name, the system will create it like that. Now I'm dropping this constraint. Sorry. Now I'm dropping this table. Now I'm trying to retrieve the data from this table. See, now I don't have any constraint information here. Now simply I'm mentioning like as a primary key. Now I created this. Check this in user underscore text. So earlier we have 8639 now. Now if I drop this, I'm going to create with again 8639 we have earlier. Now it is creating 8640. Okay. See, Now, if you haven't provided the constraint, how can we provide the name to the constraint? So you are providing the constraint type, not with name, right? See now, simply you need to do like this: const constraint name cns underscore pk. The name should be valid. So you are making as a constraint cns primary key as a pk. For which column you are going to mention, that you need to mention acno or ano. The name should be the naming conventions you need to follow as a valid manner, valid name. The column, the constraint name need to be understand. This is the primary key constraint on this particular column you are making this. Okay, constraint name, and constraint type. So now see the name is already used by an existing object. Okay, now I drop this and I'm recreating this. See, earlier you are seeing this as a default values sys 8640, right? Now I made this as my own name, cns underscore pkano. Now you can check this. See, the constraint name got updated with my own name. Everything will same, but the constraint name I provided myself, right? So this is one thing. And see every constraint. So you can able to provide the constraint name, not null also. So if you want to provide the not null constraint, so mention like NN, not null, not null for name, NM. So you can able to mention like a not null, not null. So you can verify it. Now the constraint having my own name, not null constraint. Okay. So now this is the advantage of this creating of this, right? So now you are creating this as a column level till now. Now I'm making as a table level. So instead of providing this constraint here, I'm cutting this and making as a table level. Simply, if you want to derive any constraint, so you can derive the table with all column definitions. Column definitions in the sense column name, data type, what the things you are mentioning here, that we can call it as a column definition. This we can call it as a column definition, data type and size of that particular column. Table definition in the sense the column inside the what are the columns we have, what is the data type of that entire we can call it as a table definition. Table definition. So this we can call it as a column level column definition. Okay. See, after completion of all the column definitions inside the table, after that use like a constraint name, constraint constraint name, primary key, the constraint type. See, you don't know like you are looking for the whole family. Now, to whom you need to provide this constraint, that you need to mention. Simply ACNO. ACNO. Now, drop this table and recreate it. So you can verify. Everything will sing. Everything will sing. You can derive it the, see, you can able to do some task with two ways, but the output will be same. See, sum of two numbers. See, a plus b equals to, you will get some value. B plus a also you will get the same value. The functionality won't be changed. 2 plus 3 equals to 5. 3 plus 2 equals to 5. 2 plus 3 equals to also 5. The functionality will be same, but the the execution part is a different. Okay, so you may assign the value like a equal to b or b equal to a, some anything like, see, the functionality will be same if you derive at the column level, if you derive at the table level. But there is some advantage at the derivation of the column at table level. See, the advantage is earlier you are not able to derive this primary key for two columns, more than one column. You are not able to derive this constraint at two columns. Now I'm trying to do with two columns. See, simply I'm deriving the constraint with pk, ANO, and as well as the name. See, to understand this, I change the name here. Okay, not required to change the name. Okay, primary key of ACNO, comma, name column. See, now the table has been created with two columns. You can check this in this place. Account master is having two constraints. So you don't know like, so this constraint is related to which column you are not able to get in this, right? See how you are able to get the information about the table of columns, user underscore tab underscore columns, right? So the same way you can able to get the user underscore cons underscore columns, user underscore cons underscore columns. See, now we have the two constraints. CNS underscore name is one, that is for the name, for name column. So the same constraint PKNO, PKANONM is another constraint. It is having the two columns of the same constraint is having with the two columns. First ACNO is one column and name is the another column for this. So in which order you provided that, in this same way you are getting and creating this constraint. This is the advantage of deriving the table level and column level. So deriving the column level, you can, the constraint is fixed, like fixed for that particular column itself. So you cannot able to make as a composite primary keys, a composite of any key. So not only with the primary key, you can mention simply unique also, unique. So now I'm dropping this table and I'm trying to make this. See, you can able to make the constraint with two columns as a unique constraint. Okay. See, now we did with the constraint. See, now same way, instead of deriving the not null constraint here, the column level. So now I supposed to mention the for not null constraints also with two columns. Simply I'm mentioning like a not null of ACNO comma name. It give the error for you. Give the error for you. See, invalid identifier. It is giving the error because not null constraint can work with that only at column level. You cannot able to make a not null constraint at table level. You cannot able to make not null constraint at table level. You cannot able to create not null constraint one column at the table level or two columns at the table level also. Because not null constraint works at the column level only. And check constraint, you can able to derive the check constraint at column level as well as the table level. Okay, so now we learn about how to providing my own name to the constraints, right? So you provided your own name to the constraints. Okay, and how many ways we can derive the constraint, the table level and column level, two ways. And the primary key. And what is the primary key? What is the meaning of composite primary key? See, composite primary key, if you are creating the constraint and based on more than one column on any constraint, that we can call it as a composite. If you are creating a single constraint, I mean, a single constraint with single column, that we can say normal primary key. If you are creating with a single constraint with two columns, or like one or more, more than one column, that we can call it as a composite primary key. 2, 3, 4, 5, 6, n number of columns. Okay. So then, see, you are deriving some of the columns as a default constraint, right? See, we are seeing all the constraints you are seeing in the user underscore constraint. Now I'm making as a init, passing the default value as a gender. default in. See, you cannot able to provide default constraint name, constraint CNS underscore DFLT. See, the constraint specification not allowed here. The constraint specification is not allowed here. You cannot able to derive their own name. You need to use in this particular way. Now the table has been created, right? So you can check this, how many constraints we have in this particular, see, default constraint. We won't store that value anywhere. See, CNSPKNO is only one constraint which you derived in this case. Okay, but there is no other constraints. You can check this. Default constraint value is present in any of the columns. See, you are not seeing any column, such type of columns, the gender, but you can get that in user underscore tables. In user underscore tables, maybe you will get that information. User underscore tab underscore cons. See, here you may see some default val. Okay, you may see the default val. See, data default is n. We want to know about the default constraints, that you will see this in data default is the value for that particular column. This is the default constraint. So you need to verify the things like this. Okay, till now we see about the constraints which we are using on the daily basis, and we have one more constraint, is a foreign key constraint. Is a foreign key constraint. See, till now you are working with a single table. See, if you want to provide your address with any other person, So earlier, the people is writing like postcard, right? The postcard is having like address information along with the son of operation. So why will give the son of? It is referencing like this is your parent. So I'm the parent, I'm the child of him, right? So you are always taking the reference of that to get like your identity, right? See, the primary key is a parent table. Treat like I say, primary key is a parent and foreign key is a child table. So if you have the primary key, take some Excel sheet, then you can get a more clear picture for this. See, have the two tables like parent and ID, name, so age kind. So you may have like more other values also. 1, 2, 3. So I have three values. I'm mentioning like A, B, C, and A is like 35. Now how this parent table? Now I'm deriving this and I'm maintaining the child table, child information. Okay, so I'm maintaining the child information here. Child. So CID, child ID, C name, C age, and you are referring the like PID, parent ID. Okay, so you may have all the other columns also. If for now I'm deriving this, CID 100, 101, 102, 103. Now I'm mentioning like P, Q, R. Yes, we have this. Now I'm mentioning like 10, 11, 11. So 13 is my response. See, while inserting of the child information into the parent table, while joining into some organization, see whatever the information you are giving about your family that need to be validated. See, now if you are in like Gulf countries or if you are in the other countries, right? See, and if you are in the India, so you are the Indian member in the sense. So you will see like if you are like um, if you are in any trouble, so if anyone is asked come to like so which is your native place, so like from which place you are belonging to some kind. See, I'm from AP. Is there any identity for you? So the Aadhaar number, Aadhaar card, you can able to showcase that. The Aadhaar number is the NEQ ID for all the things. You can able to validate. So using that Aadhaar ID, so is there any Aadhaar number in this particular place? So you can able to download from UID site and you can validate he is belonging to India or not. There is an option to validate that, right? So now while inserting of any member into the while joining into some X or some school or college anything, see these people will ask the your parent details. Okay, so before joining any person into the child, okay, sorry, any child in the some school or college in such place, you need to validate that parent is whatever the child is saying, like my parent details is this. The parent details given by the child is need to be validated. If you want to validate that, we'll use the foreign key constraint for this. See, the child 100, the child P is saying like my parent ID is 4. Actually, I have all the parent information in my parent table. I have only 3 parents in my family, like 1, 2, 3, 4, 1, 2, 3. There is no 4 PID as a parent ID. See, he's saying like a wrong thing or a mistake, like he's giving some fraud values. It need to be restrict. It need to be restrict. So while inserting of the parent information must and should be present in the parent table. It need to be validated. If it is not present in the parent table, it need to be restrict. Parent key not found. Parent key not found. So if you are trying to insert with 3 for the Q person, it need to be allowed because 3 is a valid parent ID. Valid parent ID. And same way, if you are trying to insert with other things like 1 need to be allowed, 2, sorry, 3, I am trying to insert for 3 also. See, every parent may or may not have the child. Some people may not have the child also. So everybody like no like there is no situation. Everybody is have must have the child, but every child have the parent. Definitely, every child have the parent, right? See, while inserting in the data into the parent table, you cannot able to validate because the parent information we need to validate themselves. So, what are the parent giving the information? That is the different. You can able to restrict the duplicate and null values in this particular table. Okay. See, while inserting the about this parent, like who are having the childs, while inserting the data, child information in the child table, you need to be validate with parent table. So you need to link with these two tables and validate it. If you want to do that operation, you need to use foreign key constraint for that. Foreign key constraint. See, foreign key constraint will help us to link the tables. Link the tables. See, it is used to maintain the reference from one table to another table. See, you are giving the reference in a sense, you are linking them as a one table, or you are linking the two tables using the foreign key constraint. Foreign key constraint. So this help us to simply by mentioning, we are saying like giving the reference of this, right? See, take this of any one of the parent table and insert this. ID, primary key and name, I mentioned it. And I'm trying to insert like CID, CNAME, and PID. I'm not inserting more columns here. See, while creating of this table itself, I'm creating the child table. and I'm giving the reference. See, PID values while providing the value of PID, and I'm taking the reference of parent table of ID column, parent table of ID column. See, parent table of ID column here. Now I'm giving the reference of parent table of ID column in the sense it is linking with this child table with the parent. Now the table has been created a link with this, and I'm inserting the data into insert into parent values. So 1 comma A, so 2 comma B, 3 comma C. Okay, I inserted the three values 1A, 2B, 3C. Now I am trying to insert this child values, child ID, insert into CID values, and I'm trying to, so 100, the child name will be P for one child, and I'm trying to insert a value like PID. The value must and should be present in the parent table. Okay, now I'm inserting with that one. See, I'm saying like, okay, so it is allowing the value. The child ID is any key value or any value from your end, you can provide that. The child name, your wish, while providing of your parent information that need to be present in the parent table, else it give the error for you. See, you provided this list of values, so it allowed. Now I'm trying to retrieve 101. I'm going to insert. I'm making as a parent ID as a 4. The user or the child name is Q. See, it is giving the error. Integrity constraint violated. Parent key not found. Parent key not found. So I said like if you are trying to insert any child information, the child of parent ID must and should be validated from the parent table. If the value is not present, like if you are inserting 4 here, that need to be errored out or giving the it must give the error for that as a primary key not sorry parent key not found. See, if you haven't give this reference, in case if you haven't give this reference, now I'm dropping this table and I'm removing this back drop table name, and I'm removing this reference of this table, then it won't be validate. It won't validate of this. You can check this and trying to insert like 100 p comma 1 and 101 p q comma 4. See, it is not giving any error for you. It is not giving any error for you because there is no validation rule on your table. See, it is not at all giving any error for you because of this. There is no relation of these two tables. You are not giving any references of this, right? So you are giving the reference here. See, you are deriving the constraint at column level here, not at the table level. So you are giving the table level. You cannot able to provide constraint name here. Simply constraint CNS RF. Cannot able to do like this. It's giving the error for you. I drop this constraint and I'm giving this. Okay, sorry. The constraint name, a reference of this parent ID. You derive this at the column level. Okay, you are able to derive this column level. And if you want to derive this at the table level, I'm copying this. I'm cutting it in this place and I'm adding some extra comma and pasting this. Now it gives the error for you. Give the error for you. Okay, give the error for you because you need to be mentioned to whom you are giving the reference in this particular family. So in the child family, having CID column, CNAME column, PID column, to whom you are giving that particular relation. So you are giving like I'm taking the relation from the parent table of ID column. You mentioned that, but you haven't mentioned about to whom you are giving this particular relation that you need to mention. If you want to make that particular relation, you need to be know about to whom you need to give the foreign key. The foreign key is the keyword. Here you need to provide the constraint name as a reference, foreign key of PID and references of parent table. This is what you need to give. Now see here, you made some constraint as a foreign key of PID column and you are giving the reference of this parent table. Now Oracle can understand this. You derived at the table level in the sense, if you are deriving the foreign key constraint at the table level, you must and should need to provide what is the foreign key value, what is the reference value. You cannot able to derive this mechanism at the column level. See, constraint specification not allowed here. It give the error for you. If you want to define the constraint, foreign key constraint, if you are deriving at the column level in the sense, you need to use only the reference, the constraint name, references of a table name, parent table name of column name. If you want to derive at the table level, you need to derive the foreign key values along with the reference constraint. Okay, this is the way you need to create the constraint. These are the constraints we have. Okay, this is about the constraint. See, while deriving this, say I forget to give this, I'm dropping this table and I created this table. I forget providing the constraints at the design of the table, at the time of design. Now, I cannot able to drop this table every time. I cannot able to recreate this table again, right? With the constraints specification. So for that reason, you can able to alter the table to add the constraint. Simply alter table child, add the constraint name, foreign key, references of this. Not only with foreign key constraint, you can able to add this constraint. Go to this place, open declaration. Check in user underscore constraints, then you will get to know things. User underscore constraints. Child. So you are seeing like CNSRF is constraint. The constraint type is a R. See here we have constraint type is R. So if you are deriving the constraint type as say unique, the constraint is unique. It defines U as a constraint type. If you are defining the primary key, you may see like a P as a constraint type for this. If you are deriving the not null constraint of for any constraint, then you can define, then it will show like as a C constraint type as a C. Not null. Earlier we don't have a check constraint, right? I mean a C value here. We have RUP. Now if you run this user underscore constraint, you may see option like C. The constraint type is a C for a account master table. See here, you have the search condition option. See what are the column is having the constraint type as a C, that particular constraint is having the such condition value. That may be anything. If you mention like a check constraint and gender in M comma F, that condition will be present in this place. Okay, so you can check this all the things from your end, and you may say another difference like here we have index owner and index name. See, if you are creating any constraint as a primary key or unique constraint, based on that particular name, this constraint also will, sorry, the index also get created at that particular column. So what is the advantage of this index? That we'll see. This create index for that particular column. If you are creating the primary key or unique key constraint, it create by default, it create a index also for that particular column. That you need to be remember. So this is about the constraints. If anyone having any doubt, ask me now. We added the constraint, right? And you can able to drop the constraint if it is not required at the table. So how you added the constraint? Simply add, instead of adding that, use like drop for that. Alter table name, drop constraint name. So the table got drop this constraint, CNS RF. You can verify it. There is no constraint for now. Okay. You can able to alter the, by using alter command, you can able to add the constraint, or you can able to drop the constraint. So this is about the constraints. It's very important because here see, till like what are the constraints we discussed. This is working with a single table. This is working with a single table of this till now. The foreign key constraint is having the integrity between the two tables. So integrity is help us to validate the data. See, if you are seeing this value, okay, see, it is not giving like a normal error, like a not null constraint. See, you cannot able to insert the null into this column, duplicates found. It is not giving like that. It is giving the error. See, integrity constraint violated. See, foreign key constraint, we can call it as an integrity constraint because you are making the relation of the table, so it linking the table. So the integrity constraint is violated here. It's a parent key not found. So foreign key constraint, we can call it as a integrity constraint also. A reference constraint also, you can call it as a reference constraint also. Okay, reference constraint meaning if we are deriving that foreign key constraint at the column level, we are calling as a reference constraint. If we are deriving at the table level, we are calling as a foreign key constraint. Okay, this is about the constraint. Deriving the constraint at two level, code number and the name. Okay, so now I'm making as a individual column name. Is giving the error invalid data type. Is giving like an invalid data type. So where we are getting the error? Can someone find out here? See, data type number 13. So number varchar 2 not null. We provided this default varchar 2 number. So reference to account number, current balance number, consent name. So where we have the error in this case. See, I forget to mention the key. See, it is giving the error earlier. If I miss any one of this, you will get the error like that. Okay. Now I'm trying to insert the data into my table. Insert into account master table, right? Now I'm trying to insert a CNO and as well as the name. I'm not inserting rest of the column values. Okay, now I'm inserting only 2 column values here. Values. And I'm inserting as a 1 is the one and the account number and A is my name. And I'm inserting it. And I'm inserting. Okay, so 2 is the account number and A is the name. It is allowing to create. And I'm trying to insert with 1 with A. It is not allowing to insert because so you are looking the independent column values 1, 2, 1. See, this 1 is already present in this particular table. It is like the constraint, unique constraint is already violated. Okay. Now, whereas in this, now I'm trying to insert with 1 comma B. Say, I'm inserting the value 1 comma A. Here I'm inserting with 1 comma B. Now, it is giving the unique constraint violation error. But the user wants to maintain the 2 different values. See, if you take the class, okay, first class, second class, third class, every class will have the roll number starting with 1. Roll number starting with 1, right? See, if I maintain the roll number as a unique number for that a student table, so that gives trouble for me. So I cannot able to give the sequence number for every student in the particular class. Okay. See, the first class who joined as a first, you will give like 1. Who joined as a last, you will give the last number, right? So I cannot able to found like this is the number is going to start from this particular class, right? I need to maintain the serial number as uniqueness to the class specific. Okay. So in such case, I will use like a here, so instead of putting like a S number as a primary key, I will use like composite primary key as a class ID also, a class number. So I will make the uniqueness based on these 2 columns, composite of 2 columns. Now see, now I'm making as a composite of 2 columns. Now I'm dropping this and I'm recreating with name also. Name. Okay. Now I'm trying to insert 1 comma A. So 2 comma A. Both are the different. Now I'm trying to insert 1 comma B. It is also trying to allow because the value is looking like as a 1A, 2A, 1B. See, 1A, 1B is different, right? So this is the advantage of the composite key where I need to maintain like a serial number as a class specific at the student table level, student level table. The same way where I need to maintain the account number at the branch specific. So I can mention like as a branch code also. See, most of the people will look for the fancy account numbers. So I cannot able to provide like more than like a 999 is account number for more than 1 people, right? So in such case, if I put like branch code as a unique code for that particular person, that can allow you can able to provide every branch have the same account number with branch specific, right? The advantage of the composite primary key or composite unique key is that. Okay, this is about composite.